much for inviting me in this occasion. So, Dr. Rakesh Sanodia was a PhD student of our department. So, yeah, thanks Rakesh for inviting me in this particular occasion. And
thank you, ma'am.
Yes. So, today I will basically talk about the applications of deep learning in dialogue systems. So first of all, I will introduce what do we mean by dialogue systems, and then we will show you some applications of deep learning for solving various components of dialogue systems. So already I am introduced. So I am currently an associate professor and head of the department in the Department of Computer Science and Engineering, IIT Patna. And this is my web page, and my email addresses are this one. So if you have any question regarding today's talk, you can always email me, and you can visit my web page to get further details about the about these proposed systems. So this is a kind of overview of my talk. So first of all, I will define what do we mean by a dialogue, then what is a dialogue system, and then there are different components of a dialogue system like dialogue act classification, intent detection, slot filling, dialogue management. So all these components I will try to briefly describe, and then I will show some of the applications of deep learning based techniques for solving these problems. So basically, if there will be any issue with my audio or video, please let me know. Because in this online system, it is very difficult to understand whether I am fully audible or visible. So if there will be any issue, you can unmute yourself and you can just talk, you can just mention. So this is basically, this is a kind of a dialogue system. So there is a chat bot or the virtual agent, and there is a customer. Nowadays virtual agents or the chatbots are very common in our day-to-day life, like the Alexa, Siri. These are examples of chatbots, and they are basically developed to solve problems of our day-to-day life. So almost all the customer care representatives are nowadays replaced by the chatbot. So this is a virtual agent or a chatbot. So chatbot is saying, hello, how can I help you? And the customer is saying that, yes, customer is saying that I am facing some problem, like my computer isn't working. So then chatbot will try to gather more information from the customer related to the problem statement that the customer is facing. And then it will basically try to solve the problem. So basically, finally, the user is very happy, great, that solved my problem. And he is basically thanking the customer chatbot, and chatbot is saying anytime. So this is basically a kind of a dialogue system. So what is the definition of a dialogue? A formal discussion of a topic in speech or writing. This is a connected series of utterances, a text or conversation, exchange of ideas or opinions on a particular issue with a view to reaching an amicable agreement. So basically, formal discussion on it of a topic in speech or writing is basically called the dialogue. So it is a connected series of utterances. Sometimes the customer, the chatbot is saying something, sometimes the user is saying something. So it is a connected series of utterances. And basically, there are multi-party, there could be multi-parties or two-party. And basically, they are exchanging some ideas or opinions on a particular issue with a view to reaching an amicable agreement. So there are several characteristics of a dialogue, like whose turn it is, what are the intentions, how to reply back. So these are the different characteristics of a dialogue: whose turn it is, what are the intentions, and how to reply back. So if you see, this is the overall dialogue system. So dialogue system is basically having two major components: natural language understanding. So this natural language understanding module is basically responsible for understanding the user utterance. So suppose user is uttering something like here, which restaurant can I book for 2 people for today? That is the user utterance. Now extracting information from the user utterance is basically called natural language understanding. So this natural language understanding is having three components: dialogue act classification, intent classification, and the slot filling. And you can see that dialogue act classification means to understand the communicative intention of the speaker. So which restaurant can I book for 2 people for today? So this is an example of a question. Then intent classification means to understand the intent of the user. For example, booking a restaurant, that is the intent of the user. So from this user utterance, we need to understand the dialogue act. So dialogue act is basically the classification of the state of the utterance. So for example, here this is a question: which restaurant can I book for 2 people for today? So this is an example of a question. And the intent classification means we need to understand the communicative intention of the speaker. So here intention is booking a restaurant. So you need to understand that the communicative intention is booking a restaurant. And then the slot filling in, basically extracting information from the user's utterance. So for example, here the important slots are 2 people and today. So these are the 2 important slots, and we have to somehow extract these important slots from the user utterance. So finally, after gathering information about the dialogue act, intent, and the slot, those information are captured in terms of a state representation. So state, basically, state is a collection of dialogue act, intent, and the slot. And then basically this state is like, for example, state is basically given as an input to the dialogue manager. So dialogue manager basically takes the state information as the input, and then it basically, that dialogue manager basically is a kind of reinforcement learning based agent. So based on the state, it basically picks an action, and then this action is translated into system response by the natural language generation module. So user is saying something, there is a natural language understanding module. So this natural language understanding module is basically understanding the different, identifying the different types of information from the dialogue. It is understanding the what is the state, what is the type of the utterance, then what is the intention of the user and the slots, and then this that is given as a state to the dialogue manager. Dialogue manager is basically mapping the state into action, and action is translated into system response by the natural language generation module. So now we will see the first task, which is the dialogue act classification. So dialogue act classification is basically to understand the communicative intention of the speaker. So whether the speaker is uttering a greetings, or it is a question, or it is a statement. So the type of the utterance is basically called the dialogue act. Like what kind of experience do you have then with the child care? This is an example of a question. I think it is really, this is an example of a statement. How about you? This is an example of an open question. That's all right. This is an example of an understanding. So here we have used 2 data sets, which is one is called the switchboard data set or HWBD data set. So this HWBD data set is an informal corpus of human-human interactions. It is consisting of 1,155 dialogue conversations amounting to more than 2 lakh utterances. So there are 42 categories of dialogue acts. There is another dataset which is called a trends dataset. It is a task-oriented corpus where an user collaborates with a planning assistant to accomplish some task involving manufacturing and shipping goods in a railroad freight system. So it comprises of 98 dialogues amounting to about 7,000 utterances. So basically these are the 2 datasets that we have used for our task. One is the switchboard dataset where there are 2 lakhs utterances, and there are 42 categories of dialogue acts, and there is a trends dataset where there are 7,000 utterances. So basically, first of all, we have developed some machine learning and deep learning based approaches for dialogue act classification from text. So here only the textual version of the utterances are given. So we have the textual representations of the utterances, and now we have to basically predict the dialogue act. So here, first of all, as the switchboard corpus is having 42 categories, so it is very difficult to deal with these 42 categories. So we have basically used we have basically somehow grouped this some of the tags into some higher level into some coarse grain tags. As the switchboard tag set has fine grain categories, not very useful for restricted domain applications. So we proposed a new possible taxonomy that can divide the utterances into some generic classes. So here the proposed classes are question, acknowledgement, greeting, general, statement, and command. So these 5 classes are used to basically, 5 classes are used to represent the switchboard corpus. So we have the question, acknowledgement, greeting general, statement, and the comment. So these are the examples. Like question means it contains utterances that represent any type of question, like who is Chris Manning, what is your name. These are the example of a question class. Then we have a greeting general, involves greetings, goodbyes, and basic small talks, showing expression of gratitude towards listener. Good morning, good evening, good night. These are the examples of the greeting general class. Acknowledgement of the cat. This involves explicit affirmations, disagreement, or confusion from the user side, as well as the instances that indicates end of the conversations. So this involves explicit affirmations, disagreement, or confusion from the user side, as well as the instances that indicates end of the conversations. Like yeah, okay. So these are the examples of the acknowledgement of the cat. Now comment, this involves asking the system to perform an action which may include display, search, generate, etc. Example, pass the book. Now there are some statements of the information utterances that contain any piece of information that can be used to extract attributes. Like he is in Austria right now. So this is an example of a statement. Utterances that contain any piece of information that can be used to extract attributes. So this is an example of a statement. He is in Austria right now. So these are the 5 categories that we have used in our task. Well, one is the question, then the greeting general, third is the acknowledgement or cat, fourth is the comment, and fifth is the statement or the information. So for example, an example of a dialogue you can see, like agent is asking, hello, how may I help you? So this is an example of a greeting. Then user is saying, show me flights to Mumbai today. So this is an example of a comment. Agent is asking, may I know the departure place? So this is an example of a question. User is saying, oh, it's Bengaluru. So this is an example of a statement. Agent is saying, so you want to fly from Bengaluru to Mumbai? It is an example of a question. User is saying, yes. This is an example of acknowledgement. Agent is saying the flights are GS 383 at 2 p.m. and IN 541 at 10:30 p.m. This is an example of a statement. User is saying thank you for the information. So this is the overall architecture of the proposed work. So there are some data pre-processing. So we are processing the data. Then we are preparing the taxonomy. So these classes, originally, as I mentioned, there are 42 categories. So we are somehow merged these 42 categories into fine coarse grain categories. So that gives us the basically a taxonomy. So we basically prepared the taxonomy. And now basically we annotate the data with this taxonomy, with this particular classes, we annotate the data. Now there are different types of feature engineering. In some cases, we are manually extracting some features which are useful for this particular task. So there is a manual feature engineering process. And also there is an automated feature engineering process where word vectors are basically developed. And then, word vectors are deep learning based tools by which we can generate the vector representations of the words. So like word2vec, globe, these are some deep learning based tools available which can take a particular word as an input and it basically produces the vector representations of the word. And these vectors are semantically similar. Like if two words are semantically similar, then their vector representations will also be very much similar. So we can either use the word2vec or to generate the vector representations, or we have all the features. So now there are 3 different models. In the first model, manually extracted features are passed through the CRF layer, and then there is a dialogue act classification layer. So we are manually extracting many features. We are passing them to the CRF layer, and then finally we are categorizing the dialogue act. This is the first approach. In the second approach, basically you can see that we are adding the word vectors. In the methodology 2, we are adding the word vectors with the handcrafted features. But now there is a feature selection technique. We are selecting some important features. So there is a feature selection technique by which we are selecting some important features. And then those features are passed through the CRF layer, and then we are getting the classification. So this is the methodology 2. Here it is basically, here we are extracting some features, as well as we are applying some feature selection technique. And after feature selection technique, we are passing them to the conditional random field, and then we are doing the dialog act classification. In the third type, we are applying a clustering technique on the word vectors. So we are now grouping the words based on their semantic similarity. So if two words are semantically similar, then those will be clustered into a single cluster. So this way we are clustering the word vectors, and we are forming some clusters. So these clusters are semantically similar. So basically, there are some if some words are semantically similar, then they will fall into one cluster. And now the word is replaced by the cluster ID. We are now no longer using the original word vector representation of the word. Rather, we are replacing the vector representation by the cluster ID. And then we are passing them through the CRF layer, and finally doing the dialog act classification. So this is the methodology 3. So these are the three methodologies: methodology 1, methodology 2, and methodology 3. All these three methodologies we have applied on our data set. So as I mentioned earlier, methodology 1 is using the conditional random field. So it is a sequence leveling task. So we are extracting many manual features: lemma form of the words, lemma bigrams, part of speech tags and their bigrams, speaker information. So lemma is basically the root word of the word. So we can remove the prefixes and suffixes, and we can get the root word, and also we can get the root word of the two consecutive words. That is called the bigram. Similarly, we can identify the part of speech of the word, and then that is called the part of speech tag. And also we are considering the bigram of the part of speech. Then speaker information, who is the speaker of the particular utterance. And then there are some class specific features as well. Like suppose if it is a question, then we are seeing whether the sentence is starting with this 5 WH words like what, where, when, which, who, how, and question mark. See if the sentence is starting with any of these WH words and also with the question mark, then there maybe we can assume that this is a question. Then greeting general, presence of sorry, thank you, hello, hi, etc. And the cat means present of hua, okay, yes, no, etc. So these are the class specific features. So we did an ablation study. We have manually extracted these features. So we perform experimentations with all the features, and also if we are applying some feature selection technique, like we are initially starting with a single feature, then we are keep on adding some features into it, and in a forward direction we can make some ablation study. So this is called the forward feature selection. So we have conducted an ablation study in the forward direction. It is the features are combined one after the other. The difference in the accuracies is used as an estimate of the importance of the feature. The best performing features are taken and rest of the features are dropped to reduce the complexity. So the methodology 2, as I mentioned, that here we are using the word-to-vec representations of the feature of the words. So we have used the globe or the word-to-vec, and we are generating the vector representations of the words. And then basically, we are here this word embeddings of the words are basically used for the methodology 2. Best performing features obtained from the ablation study. So there are two types of features: best performing features obtained from the ablation study and the word embeddings of the corresponding words. And these two types of features are somehow combined, and then we are passing through the CRF layer.
Hello, ma'am. Are you here?
Yes.
We
Sorry.
can't hear you.
Yes. Yeah.
Oh.
Am I audible now?
Yes, ma'am. Yes, ma'am.
Yeah. So this is our methodology 2, where we have done we have generated the embeddings of the words. So we have used this pretend Google News word embedding of dimension 300, and we are generating the word embeddings of the corresponding words, and then the best performing features obtained from the ablation study. So in the previously, I have mentioned about the ablation study. So we have extracted some features by the ablation study. And now we are adding the word embeddings with the ablation, with the features which are selected by the ablation study. We merge them together and then we pass through the CRF layer. And then we are basically able to, we are solving this particular, this is the methodology 2. And now in methodology 3, basically now we are applying the clustering, as I mentioned earlier, that we are applying the clustering on the word embeddings. We are grouping the words into their semantic similarity, and then each word is replaced by the corresponding cluster ID. So base performing features obtained from the ablation study are the lemma unigram, lemma bigram, part of speech unigram, part of speech bigram. So this is the methodology 3. And you can see this, like you suppose there is a sentence, show me flights from Denver to Baltimore. So we are getting the what embeddings from the show me flights. So these are the vector representations of show, vector representation of me. So we're getting several word vectors, and each word vector is of size 300 dimension. So we're getting the vector representations of each of the words. And now we are applying the clustering technique, and we are grouping the similar words into a particular cluster, like Baltimore, Denver, New York, all the grouped together, from, to, in are grouped together. So basically we are now applying clustering on the word level. And then you can see that now each word is basically replaced by the cluster ID. So show is a part of the G_3 cluster. So now we have replaced the word embedding by the cluster ID only. So this way we are generating some feature vectors. This is the third methodology, and in the fourth methodology we have used a deep learning based technique. So here CNN convolutional neural networks are used. So we have used a CNN with the fixed filter size of 3, CNN with the multiple filter sizes of 3, 4, and 5, and to the baseline variants of RNN such as LSTM were incorporated. And we are first of all we are trying to extract some features, hidden features, through CNN, and then we are also trying to add the part of speech and the cluster ID features before the last layer. Before passing through the classification layer, we are planning to add the features extracted from the CNN with the part of speech and the cluster IDs, and then pass them through the classification layer. So this is our proposed architecture. So you can see that we have the sentences, we have the word embeddings. Word embeddings are passing through different CLL layers with different filter sizes. Filter size of 3 into 3, filter size of 4 into 4, filter size of 5 into 5. We also have the part of speech or the cluster embedding. Those are again passed through some CNN layers. Now we are extracting some hidden features, and then all are concatenated together. And finally, we are passing through the RNN unit and then followed by the dense layer to produce the output. So this is the overall architecture of our proposed Dialogue classification task. So you can see that now the results, as I mentioned, that originally the switchboard dataset was having 42 tags, but now we have somehow merged those 42 tags and we created a new taxonomy. And this taxonomy is having only 5 tags. So these are the comparative results. So with all the features, as I mentioned earlier, we have extracted the lemma diagrams, part of speech diagrams. Then we have some class specific features, 5 W features. So we have several features that we have manually extracted. And with all the features, we are getting the accuracy of 72.50 and F1 score of 48.08. But with only 5, if we are using our proposed tag set, then we are getting the accuracy of 90.87 and a F1 score of 76.17. Now, you can see that we have also done an ablation study, as mentioned earlier, that we are selecting some few features from the set of all the features. So now there is a, in the accuracy wise, you can see there is a drop, and also F1 score wise with the original tag set there is a drop. But when you are using our tag set of 5 tags, then there is an improvement in the accuracy, and also there is an improvement in the F1 score. So now with the methodology 2, when we are using all the word embeddings, then you can see with the original tag set and with the proposed tag set, these are the results. But when we are adding the base features by the ablation study, some base features are selected by ablation study. If we are adding those features with the word embeddings, then you can see there is a further increase in the F1 score, and also further in the case, there is F1 score is very low, only 14%. But if we are adding the cluster ID with the base features, then you can see there is a huge jump in the accuracy and F1 score with the original tag set as well as with the proposed tag set. So, and with the now with the CNN based architecture, you can see that with our proposed tag set, we are getting 90.26 accuracy. When we are using the part of speech features only, and when we were using the cluster cluster ID as a feature, then our accuracy is 3. So these are some error analysis. Like suppose if the utterance is, can you tell me the way to Patna? So this is your example. Predicted is basically a comment, but originally this is a question. Basically, can you is having the 2 literal meaning. I am going to Lucknow, book me a hotel there. So this is an example. This is basically predicted is information. Original is basically it is a comment, but as the sentence is not starting with a verb, so the system got confused. The system identified this as an information. Okay, I will also come tomorrow morning. As it is starting with the okay, so the predicted is basically cat, because you know all the cat utterances are starting are kind of this okay, sure, etc. But basically it is an example of information. So what could be the reason for the misclassification is that cat has much occurrence of words like okay, yeah, etc. No, it's not possible. So there here the prediction is basically information, and the original is basically cat. Basically, it is replying to a question. So now I would like to show you how multimodal information can better help us in developing a dialogue classification. So till now, the approaches that I have mentioned are based on only text. So you have the textual description of the utterance, and we are applying our proposed approaches on the textual description of the utterance. So it was not, we have not used any multimodal clues for solving the particular task. But now I will show you how multimodal information like the audio features and the video features can also help us in understanding the communicative intention of the speaker. So like here we have proposed a task towards emotion-aided multimodal dialogue classification. So you know that here primarily, if you see all the task of dialogue classification, they're mostly focusing on the text part of the they're only considering the textual description of the utterance. So we have the textual description of the utterance, and based on that we can say what is the communicative intention of the speaker. But the speaker is having many other non-verbal features, like there is a change of tone, facial expressions. So these can also provide us much information about the communicative intention. So basically now our task is to consider this multiple information. So if there is what is the audio signals and what is the facial expressions. So after considering the change of tone and the facial expressions, we would like to understand the actual communicative intention of the speaker. So the speaker is basically, now we are considering 3 modalities: the textual description of the utterance, the audio signal of the speaker, and the facial expression of the speaker. So the emotional state of the speaker has a substantial effect on the pragmatic content. So this is another assumption, that what is the emotion of the particular speaker, that also determines the communicative intention. So suppose if the user is sad and user is saying okay, sure, then that is a kind of an agreement. But if suppose the user is angry and it is saying okay, sure, then this may be in the context of a disagreement. So the emotion of a speaker can help us in better understanding the communicative intention. So basically, so in this particular work, this is a novel in the sense that this is the first work where we have basically combined the multimodal
circumstances. So madam was not able to continue his lecture. So now I request ma'am to continue his lecture.
Yeah, Rakesh, am I audible?
Yes, ma'am.
Yeah, I am extremely sorry. Actually, there was some power cut and also
Yes,
internet
yes.
issues at my place. So there was a disturbance during my talk. So yeah, let me just I will take half an hour just to complete this topic. So as I was discussing about these dialogue systems, so already I have mentioned that the dialogue system is having many subcomponents. One component is called the dialogue act classification. Then we have the intent detection, slot filling, dialogue manager, and the natural language generation. So I was discussing about the dialogue act classification. So dialogue act classification means that to understand the communicative intention of the speaker. So what the speaker is trying to say, whether this is a question or it is an open statement or it is a greeting or it is a command. So that classification is basically called the dialogue act classification. So in my afternoon talk, I was discussing some machine learning and deep learning based techniques which can be applied for solving this dialogue act classification problem. So now I would like to show you some, work where we have used some multimodal signals. Like now we are not only relying on the text format of the dialogue, but also we are using the image and the audio and the video signals. So if you see that this is the basically the motivation of this particular work, that the non-verbal features like the facial expressions, the audio tones, those are also important to understand the communicative intention of the speaker. So if you see the facial expressions or the eye movements or the audio tone, we can easily understand whether the speaker is saying that particular utterance is a command or it is a kind of a statement. So basically tone or the facial expressions provide us much clue. So this is the first work where we have incorporated the text plus audio plus video signals to predict the dialogue act of a particular utterance. And the second thing is that we also consider that emotional state of the speaker has substantial effect on the on the pragmatic content. Like if we can also try to understand the emotional state of the speaker, then it has a huge impact on the dialogue act. So suppose, as I mentioned earlier also, like if the user is happy and saying okay, sure, or yeah, right, then maybe it is a kind of a agreement. But if the user is angry and he or she is saying okay, sure, yeah, right, then it can be considered as a disagreement as well. So in the expressive DAs like the greeting, thanking, apologizing, etc., speaker's emotion can be basically speaker's emotion can play important role in understanding the communicative intention. So basically in this particular work, we have proposed a deep learning based architecture because we have to deal with these multiple modalities. We have to extract features from the audio, video, and the text side. So we have used the deep learning based technique, and also, attention plays a very important role because when you have to deal with multiple signals, alignment is required. So you need to align the text vectors generated from the text side with the vectors generated from the audio or the video side. So this alignment is basically done based on some attention representations. So basically here in this particular work, we have developed a attention-based multitask, multimodal deep neural network for jointly optimizing the dialogue act classification and the emotion recognition. So here emotion recognition is has been treated as an auxiliary task and aiding the primary task, that is the dialogue act classification. And basically here it is a multitask framework. We are trying to solve two tasks simultaneously. One is the emotion recognition, and other is the dialogue act classification. So our aim is that by incorporating the emotion information, we can better predict the dialogue act. So as there was no existing data set where multimodal information was present, as well as the dialogue act information and the emotion information both were present. So we also curated a new data set, which is called the multimodal emotion DA or the EMOTIDA. And this EMOTIDA data set, each sample is having three modalities: text, video, and the audio. And then basically each utterance is having two classes, one for the dialogue act, another for the emotion. So basically we have introduced a task which is called the emotion sentiment. Basically we have introduced a task which is the emotion aware dialogue act classification in a multimodal setting. So for the dataset collection, as I mentioned, there was no dataset where multimodal signals were present, as well as it was annotated with the dialogue act and the emotion categories. So we basically scanned the literature for the existing some multimodal emotion recognition datasets. So we find out two datasets. One is called the IMOCAP and it is called the MELD. So these two data sets are multimodal emotional recognition data set. But dialogue act classification was not present in these data sets. So we manually annotated these two data sets with the dialogue act. So this switchboard corpus is having 42 dialogue acts, and but we have not used this 42 tags. We have selected 12 most commonly occurring tags, and we have annotated our data set with these 12 tags. So what are these 12 tags? Greeting, question, answer, statement, opinion, statement, non-opinion, apology, comment, agreement, disagreement, acknowledgement, back channel, and others. And we are collecting samples from two data sets, IMOCAP and mail. And there are some, the differences in the emotion annotation of these two data sets. So to remove the discrepancy in the number of emotion tags of IMOCAP and mail, the joy tag of the mail dataset was mapped to happy tag of the IMOCAP to finally settle to 10 emotion tags from the IMOCAP for the emoted dataset. So basically, we have manually collected samples from the IMOCAP and the mail dataset, and then we have basically manually assigned some tag to these datasets. We have manually assigned the dialogue act tag to these datasets. So finally, this emoted dataset is basically having 1341 dyadic and multi-party conversations, resulting in a total of 19,365 utterances. And as I mentioned, there are three modalities: text, audio, and video. And each of this sample is having three modalities: text modality, audio modality, and the video modality. And each of these utterances is basically tagged with two categories: dialogue act and the emotion. For example, here, suppose one example is others don't snap, they sting. Here the dialogue act is a disagreement and emotion is anger. So emotion label was already available because we started like that only. So this IMOCAP and mail datasets was selected because the emotion level was already available. But now we have not seen the emotion levels. We have seen only the audio, video, and the text. And then there are some annotators. There are three annotators, and who are basically trying to annotate the dialogue or the utterances with the dialogue act. So for example, where I just checked our messages and Joshua didn't call. So this is an example of a statement. That's very amusing indeed. So this is an example of a disagreement and the emotion is anger. Or come on, pick up, pick up. So this is an example of a command and the emotion is fear. So you can see that in our final data set, which is called the Emotida, there are 48% is basically samples are coming from the IMOCAP and 52% samples are coming from the mailed. And this is a speaker distribution. So you can see that how the distribution is done. So this is some other distribution of the emotion levels. So basically, there are total 8 levels: neutral, sadness, anger, fear, happy, surprise, disgust, and the frustrated. So you can see in the IMOCAP, in the email dataset, there is no example of frustrated. Disgust is mostly available in the mail dataset. And these are the distributions of the other emotion categories in these two datasets. And this is the distribution of the dialogue act categories. So you have the statement, question, answer, greeting, apology, comment, agreement, disagreement, others,